Alright, it's time to finish up the review for Mastery Quiz 13 on this next one. Here you're supposed to get the perimeter area, the rectangle on the graph. Really to get area and perimeter you only need 2 sides worth. So I'm going to pick these 2 sides, that side and that side. And what's going to help me get both the perimeter and the area is getting the change in x and the change in y. So you do x2 minus x1, and then you get y2 minus y1. That is the rise and run. So I'm going to get the rise right here, that's 2. So I'll be taking 2 and squaring that. And the run is going to be 3. So notice the 3 to the side, 2 down. I guess it's going to be negative 2. The 3 is going to go here. I'll need to square those and add them up. You'll get 9 plus 4 over here. And when you add those up, you'll get a square root of 13. So that's the length of this side here. And I'm going to get this next side using the same method. I need to go right 1, 2, 3, 4, 5, 6. So I'm looking at 6 squared. And then the rise, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, I'll need to square that. When you square both of those, you'll get 36 and 81. And so that's going to be the square root of 117. So now I have these two lengths, square root of 113 and then the square root of 117. If you want perimeter, you're going to get square root of 13 and then add the square root of 117, and then you take that and you times it by 2. And if you want to get the area, you're going to take those two lengths, square root of 13 and the square root of 117, and you're going to multiply them together, and you're going to get some approximate answer. I'm going to round to the nearest tenth. Alright, this is going to give me about 28.8 for the perimeter, and then about 39 for the area. And that brings us to the next one. If you want to get area and perimeter of this right triangle, well, if you want to get perimeter, you have to get all the side lengths. If you want area, you need to get these two lengths because they're right next to this little right angle there, and then multiply them together and then half it. So let's get these lengths first, and I'm going to use that same method I've been doing, get the rise and the run. So this first side, let's see, the rise is 1, 2, 3, 4, 5. So I got 5. Here, let me make the square thing a little bit smaller. So 5, I'll need to square that. And then my run is going to be 1, 2, 3, so 3, and I'll need to square that. 5 squared is 25, 3 squared is 9, and when you add them up, you'll get the square root of 34. So there's that one. And let's get this next one here. The run is going to be 1, 2, 3, 4, 5 again. And the rise is going to be 1, 2, 3, so negative 3. Oh man, I messed these up. These should be reversed. My bad. Anyway, when you square those, you're going to get 25, and you'll get 25 and 9. When you add them up, you get a square root of 34. And then let's get this final side here. That has a run of 1, 2, 3, 4, 5, 6, 7, 8. A run of 8, which I'll square. And then a rise of 2, which I'll square. 8 squared is 64, 2 squared is 4. Add them up, you're looking at the square root of 68. So now, if I want to get the perimeter, but smaller, I'm going to take those and add them up. So I got square root of 34 plus the square root of 34 plus the square root of 68. I'm going to play on the calculator in a sec. And if I want to get area, I'm going to do the square root of 34, and I'm going to times it by the square root of 34. And I'm going to take that and 1/2 it because it's the area of a triangle. Well, square root of 34 times the square root of 34 is the same thing as the square root of 34 squared, and square root and squares cancel each other, so really this is 1/2 of 34, which is 17. So that's going to give you an exact answer. And the other one, it's going to give you about 19.9. And that brings us to the last section where you're supposed to prove that the shape is whatever it is, in this case a parallelogram. In order to do that, you have to get the length and the slope of each side. So I'm going to start with your B, A. So I'm going to start with the length part of this. I'm going to use that same method. I'm going to go 1, 2, 3 to the right. So that's the run of 3. And the rise is 1, 2, 3, 4, 5, 6. Square those guys, add them up. And that's going to give me, let's see, it's 9 plus 36, which is, 9 plus 36 is 45. And the slope is 6 over 3, or just 2. Okay, so I got length and slope. And I notice right here, ED looks awfully similar to the slope. If the slope matches, obviously it's 1, 2, 3, 2, 3, 5, 6. So that slope is also 6 over 3, which is the same thing as 6 over 3, which is 2. And so it's also going to have a distance of the square root of 45, just like that guy there. And then brings us to AD, which has a slope. Okay, if it's horizontal, the slope is 0. Mostly because the rise is 0, but the run, let's look at the run real quick. There's going to be 1, 2, 3, 4, 5, 6, 7. And so the length of AD is going to be 7. It's just 7 long. You can count that out. 7, and the slope is, in fact, 0. And BE, we got the same starting on 1, 2, 3, 4, 5, 6, 7. This one has a, so from B to E is 7, and the slope is 0. It matches up. And then bring us to E, use results, and explain why it's a parallelogram. Well, since the opposite sides match, and the slopes for those opposite sides match, this is a parallelogram. So let me put that down in the mathematical notation. And yeah, so yeah, since the opposite sides are the same length and the opposite slopes are the same, they're parallel to each other, so the whole shape is a parallelogram. Alright, and then that brings us to our last one. So we're going to get the length and slope of each of the sides, and then go from there. Let's start with slope this time. So slope. For my first one, S to I, so this isn't counting by ones, it's counting by twos. So when I go 1, 2, 3, 4, 5, 6, that's going to be a run of 12. That goes on bottom. And the rise, 1, 2, 3, 4, 5 and a half. That's a rise of 11. So my slope's going to be 11 twelfths, which makes the distance 11. It's going to be 12 squared plus 11 squared. You square those. Alright, and then you'll square those. You'll get 144 plus 121, which is the square root of, see, you got 5, 6, 265. Okay, so this one over here looks suspect, like it might turn out the same. Let's get that one real quick. I'll get slope, and I'll see if it comes out the same. So we got 1, 2, 3, 4, 5, 6. So that the run is going to be 12 again. And the rise, 1, 2, 3, 4, 5 and a half. That's 11. So yes, we are going to have the square root of 265, just like this guy up here. And that brings us to IN. So let's get the slope first on that guy. Slope. And you're going down 1, 2, 3, 4, 5, 6 and a half, which comes out to be a rise of negative 13, because you had to go down 13. And then a run of 1, 2, 3, 4, 5, and a run of 10. And so when you get the length, you need to do negative 13 and square that, and then 10 and square that guy, and 13 squared is 169, and 10 squared is 100. So we're looking at the square root of 269. And SE looks awfully similar. Let's get the slope of that real quick. So the slope is going to be, so you got to go down 1, 2, 3, 4, 5, 6. Oh, so I totally messed up what was going on here. So this one, I messed this up. Darn it. Okay, I had to go down not 6.5. I had to go down to 6. So we start on a half and then go down 1, 2, 3, 4, 5, 6. So I just go down 6, so it's negative 12. And then when I get the distance, you're looking at negative. You're going to look at 10 squared plus negative 12 squared. And this is going to be 100 plus 144. So we're looking at the square root of 244. And the slope for this guy makes more sense. So that's going to go down 12 and then right 10. And right 10, right? 1, 2, 3, 4, 5. Yeah, so it's going to go right 10, so it's going to be the same thing, 244. And so when you say what type it is, it's a parallelogram. And what lets us know? Well, we got to write all that stuff out. The opposite sides match up, so SI is the same thing as EN, distance-wise. And those two sides are also parallel. And SE is the same distance as IN, and SE is parallel to IN. So this quadrilateral, so quadrilateral SINE is a parallelogram. Parallelogram. You think I could spell it? Anyway, there you go.